Hello, so this is François Bouteille. I will continue to show you the way in air profile in France and maybe some other places around we use diagrams and measurements in order to analyze some aspects of the operation of compressed air installations in industry. So we have defined a kind of small model or a small diagram, imaginary one, but something what you can meet, in many industries, where the usages are bag filters, some cylinders, and some regulation valves. We have been very modest. We buy the cheapest lubricated screw compressors. We buy 3 of them. It's a model of compressor which is cheaper than oil-free compressors. It's also more maintainable somehow because many people can do the maintenance for you. So loop screw compressors. And we shall be a bit more specific here. We shall say that maybe you have here something like 110 kilowatts, it's about 100 kilowatts, 40 kilowatts. This will be a 7 bar. So the flow that you may expect is around 1200 cubic meter per hour at inlet conditions. So you have 3 identical compressors maybe, and then we are going to use frigorific dryer again, but we know that some problems may occur with frigorific dryer. We have bag filters, and they are necessarily installed outside the building. It's not it's a place where you can have ice in winter, and so we think that probably the dew point we get, which is about 1 or 2 Celsius under pressure for a frigorific dryer, might not quite fit our need. So we also think that some cylinders make a lot of work, and produce mechanical work, taken from potential pressure of the compressor, and this reduces the temperature. Once expanded, the air is cold, and you may have ice also at the output outlet of the cylinders. And then the valves, we have some automation, the people who make automation sometimes are a bit touchy about compressor quality, and he wants the best possible quality because he likes very much his valves, and he doesn't want to have problems if he can avoid it, so he wants the best reasonable treatment for air, because he knows that there should be no dust, no water, no liquid water, certainly no ice, and no oil, not too much oil, because some analog regulation devices will be blocked, or will suffer, or will make wrong measurements and wrong regulation if you have liquid water or oil or dust inside the air. So at that point we decide to be maybe more clever than in the first case, and we shall see if it's true or not, and we shall install here instead of having one big dryer for everything, we shall install 3 frigorific dryers. So from here we go to the pipework, and we go into, well, this unknown pipework, unknown measurement system, and to the end usages which we have defined. So my question would be, is this system convenient or not? You know, is it convenient or not? So if you think of it, you know, it is very pleasant for the installer. The installer is very satisfied, especially if he hasn't got much space available. You know, the room, the station, the compressed air station is a bit too small. You know, and then he can find compressors with integrated dryer, which are not even bigger than the compressor without dryer. So he receives a big box, you know. He puts it on the cement on a horizontal place, and 2 hours after he can run the compressor. You know, he needs to put the power on it, and to have a pipe to the net and a valve. It opens the valve. So it sounds good, you know. It seems very pleasant for the installer. Now, the kind of problem that you can have is that if one of your compressors is out, not available, and one of your dryers is out, then you have only one set of compressor and dryer available. You know, it means that compared to a scheme where a diagram where you would have here a collector, you know, and maybe 1 or 2 or 3 dryers, you may have less, a lower disponibility, availability. So the probability that you have no good solutions because one compressor and one dryer are out of work, which happens about 2% of the time, you know, in a normal installation. And this is the ordre de grandeur, an estimate, a rough estimate of the lowest non-availability that you may have. You know, it's difficult to go strictly under 2% of the time. You know, well, during this time you will maybe send some water into the pipe work because your dryer here is out of work. Okay, so this is a module, you know, a way of making design of compressor stations which pleases the people who sell compressors, because they will probably sell a 4th module to have the same availability as with a more normal, more traditional way of doing things. It's true also that the way of doing things traditionally is not so pleasant. Why? Suppose that we do choose to have this kind of system with here valves, you know, which can be either open or closed, you know, and valves on the dryers, you know. Well, you have to install a lot of valves and then to operate these valves, you know, you need valves here in the compressors. Well, I hope that I don't miss some important valves. Well, very often the kind of things that you have is that 2 dryers are not exactly the same. You know, maybe it's not at all the same dryers. You have taken this dryer from another plant, you know, where it was not used any longer. So there is a risk that more air goes through a big dryer, you know, and only a small amount here and a very small amount here, you know. So you are never quite sure how the air will choose to go. The German would say the Verteilung, the repartition. I don't know if it exists, this word in English. I have tendency. Répartition, distribution. How it will be distributed between the division, sharing. Well, you will not know the distribution if you have this kind of thing, you know. Especially if you have here, for example, I put it here on one of the on each of the outlet of dry air, you may have here, or on the other side, now here, you may have here some filters, you know, and if these filters will se colmater, will get tapped, this is, excuse me, se colmater. Now, colmater, se colmate, clogs. If it clogs, I hope. Well, it's not a word that I use very often. Becomes clogged, blocked, you know. So if you have here a filter which is clogged, you know, it might appear like a flow reduction, you know, flow reduction. So you may have more air than expected going through one of the machines, and so as we have said, we have to think of energy and quality. So here you have a problem of quality. You may have to measure the flow by means of Venturi pipes on each of the outlets of to make sure that they work, you know, and that you don't have such a flow here, too big flow, which would be the cause of a lower quality, of a higher pressure dew point. You know, this is one thing that you can have. The other thing that you would say is that energy in this may be a problem. Energy may be a problem because you usually have all kilowatts running, you know, and sometimes it would be more interesting to have only one dryer, but a better one, which can stop, you know, 1 unit. So this was something very usual in the past with what we called thermal mass frigorific dryers, you know. They could have an electricity consumption which was proportional, you know, and this diagram is not very favorable to energy efficiency, except if you put here very efficient dryer, you know, which make variable speed dryers, for example. Okay, so for pressure, I would say that my schema, my diagram is rather better, you know, because if you have a block of ice in one of the dryers, okay, the other will have a bit more air than expected, you know, but if it is blocked completely, you do not have the pressure drop that you would have had if you have only one dryer and ice in this dryer. So thank you for your attention. I will continue to make some presentation until we think that you have understood the methods that we offer to share our knowledge and work with you.